Section 1.7 Inequalities. Properties of inequality. When A, B, and C represent the real numbers, if A is strictly less than B, when you add C for both sides, you still fulfill the inequality. You will have A plus C strictly less than B plus C. When you have an A strictly less than B, and if C is greater than 0, so C is a positive number. When you multiply the positive number for both sides, you still fulfill the inequality. A times C strictly less than B times C. What if when your C is a negative number? If C less than 0, which is going to be the negative number, when you multiply the negative number here, you need to reverse the direction of the inequality. Strictly less than becomes strictly greater than. Okay? It also applies for the division. When you divide it by a negative number, you're going to reverse the direction of the inequality as well. And this is my example using like strictly less than. You also can replace the strictly less than with greater than, less than or equal to, or greater than or equal to. You will have the similar properties. Linear inequality in one variable. In the previous sessions, we learned about a linear equation with one variable. At that time, we have ax plus b equal to 0. That's an equality. And these sessions, we're going to talk about the inequality. And this is the linear inequality in one variable. Means we only have a first degree for the x in here. Okay, types of interval. When you have a set builder notation, remember the set builder notation? This is called for all x such that x strictly greater than a, right? When we write it like this way, this is called set builder notation. And then this is called the interval notation. When you have a strictly less than or greater than, we're going to use the open interval. We're going to use the parenthesis to represent it. And then when you graph the inequality, when this is going to be strictly less than or strictly greater than, we're going to use the parenthesis. So this is x greater than a, okay? You could think about it when your x is on your left-hand side. You could put the 9 here. It looks like an arrow pointing to the right. Okay, same idea for this guy. This is talking about x is in between a and b. X is strictly greater than a and x is strictly less than b. So we want to use the open interval. Okay, this one, x strictly less than b here. Okay, one more time. When your x is on your left-hand side, you could add the line in the inequality. This looks like your arrow pointing to the left. And so that we do have the graph looks like this one. And one more time, pay attention on your inequality. If this is a strictly less than or strictly greater than, you only use the parenthesis. Okay, look at this example. X greater than or equal to a. Since we do have the equal sign here, we will be using the closed interval. That means you're going to use the bracket instead of using the parenthesis. Okay, the brackets here, this is represent you do have the equal sign here. Okay, one more time. Your x is on your left-hand side. You could add the line here. Looks like there's an arrow pointing to the right. Okay, so bracket pointing to the right. And then the interval notation is talking about a to the positive infinity. Second one, x is in between a and b. And x is strictly greater than a, okay? And this is x strictly less than or equal to b. So that's why you're gonna see we have a one parenthesis because this is a strictly greater than. And we do have a bracket for this one because we do have the equal to here. Same idea when you graph the inequality. Okay, this one, x less than or equal to b. Okay, we do have the equal sign. So for the b, we will use the brackets. And then for the infinity, we always use the parenthesis. We never have the bracket for negative infinity or the positive infinity. Okay, keep in mind, even though I do have the equal sign here, this is only talking about the b, but not the negative infinity. Okay, couple more example. This one, x is in between a and b, and we're using greater than or equal to or less than or equal to. That's why our interval notation, we use the bracket. When you're graphing, it's also using the brackets. And this one, we call this as disjoint interval. Your x is strictly less than a or x strictly greater than b. So you can see from the graph, this is disjoint, okay? They are not connected together. And then we could use the union. This is means or, okay? X is going to be strictly less than a or x strictly greater than b here. Okay, this is union or. When all real numbers, x can be anything on the number 9. So we're going to highlight everything from here. That's starting from negative infinity to positive infinity. And one more time, for the infinity, we only use the parenthesis. Don't use the brackets. Okay, now let's try to do the example together. You could just solve for your x just like the equality, okay? So here, we're gonna combine the constant. So we're gonna subtract 7 for both sides. And then you're gonna get negative 2x strictly less than negative 12. Now, we need to divide it by negative 2. Remember that when you divide it or multiply by a negative number, you need to reverse the direction of the inequality. Means you want to switch the sign. So you're gonna have negative 2x over negative 2 strictly greater than negative 12 over negative 2. Simplify it, you're gonna get x strictly greater than 6. So we're gonna write it down for the set builder notation. And we want to graph the inequality on the number 9. Okay, one more time, when your x is on your left hand side, you could just add a 9 here. It looks like an arrow pointing to the right. Okay, we do have the parenthesis here because that's a strictly greater than. And then we need to write down the interval notation. So it's gonna be parenthesis 6, comma, until infinity, and then parenthesis. And one more thing, the order doesn't matter. For the interval notation, from the left to the right, okay, starting from 6 until positive infinity. Okay, example 2. I want you guys try to do it by yourself. Write it down, the set builder notation, graph the inequality, and write down the interval notation. Okay, let's do it together. First, we're gonna combine the 9 terms. So we're gonna subtract 8 for both sides. So you should get negative 5 minus 4x greater than or equal to 2x. Now you want to add 4x for both sides. So you should get negative 5 greater than or equal to 6x. And then we're gonna divide it by 6 for both sides. And this time, when I divided a positive number, you don't want to reverse the direction of the inequality. Okay, just strictly divided by 6 for both sides. So you should find out x is less than or equal to negative 5 over 6. Usually we want to write your x on the left hand side. Okay, so we're gonna rewrite this answer. You will have x less than or equal to negative 5 over 6. Okay, graph this inequality on the number 9. So one more time, your x is on your left hand side. This is the arrow here. So you could just add the 9 here. This is talking about pointing to the left. Okay, we have the bracket because there's an equal sign here. Okay, what is your interval notation? Always start from the left to the right. So to the left here, that will be parenthesis negative infinity until negative 5 over 6 brackets. Okay, next example. And this one, we do have a 3-part inequality. And actually, you could think about it. This is a one equation. This is a second equation. Okay, we're going to combine it together. So let's do together this one. We want to isolate the variable of 6x. So we're going to add x for each side here. Okay, add x on the left hand side, in the middle, and also on the right hand side. Okay, you should get this. And then we're going to divide it by 6 for all of them. Simplify it, you're going to get x is in between 3 over 2 to 2. Okay, right? So x is in between these two numbers. So we're going to put it here. 3 over 2 is about like 1/2 here, right? This is going to be 1/2. X is going to be in between 3 over 2 to 2. And then write down the interval notation. So it will be bracket 3 over 2 comma and then 2 close brackets. Okay, right? This is solving the linear inequality. Now, let's look at the quadratic inequalities. Okay, quadratic equation. This is like the standard form, ax squared plus bx plus c. But when we have an inequality, this is going to be less than, greater than, or less than or equal to, or greater than or equal to. And a, b, c are the real numbers, with a not equal to 0. Okay, this is quadratic inequality. So how to solve it? Solve the corresponding quadratic equations. Okay, we're gonna set it up, make it equal to 0. And then solve the quadratic equation using factoring. Okay, after you find out what is your x, then we're gonna identify the interval determined by the solutions of the equation. And then we're gonna make up a test value to determine which intervals form the solution sets. Okay, let's try to do the example together. First, we're gonna assume this is gonna be a quadratic equation. Okay, I'm gonna replace the less than or equal to become equal to 0. And then I need you guys solve this equation. Factor out. You should get x minus 5 times x plus 3. Okay, 0 product property. X minus 5 equal to 0, x plus 3 equal to 0. So you're gonna get x equal to 5, x equal to negative 3. Okay, this is the step 1. Assume this is an equation here, factor out, find out the x. And then the two numbers divide a number 9 into 3 regions. So we have the number 9 here. And then we have the solution x equal to 5 and x equal to negative 3. So we use closed stock since the inequality symbols includes equality. We use the closed stock here because we do have a equal sign for our original questions. If this is a strictly less than, we'll be using the open dot. Now, these two solutions divided in number 9 into 3 regions. And we could call this as a region A or interval A, interval B, and interval C. And then we're gonna write down this interval. This solution will be from negative infinity until negative 3. And since this is closed stock, we have the brackets. Okay, from negative infinity to negative 3. And then closed stock means the brackets. Interval B. So that will be brackets negative 3 until 5 brackets. And then the last one, that will be brackets 5, comma, positive infinity, parenthesis. Okay, now we're gonna get the table here. First, we're gonna write down the interval. We have an interval A with the negative infinity to negative 3. We have the interval B and interval C. Now, the test value, you could plug in any number within this interval. So I may put in a negative 5. It doesn't matter. You could put negative 4, okay? Okay, and then the B here, second region, I could plug in any number within this interval. So I'm gonna pick an easy number. I will put x equal to 0. And then last one, this part, I will make it like x equal to 6. Okay, then we're gonna plug in the test value into our original equation. So plug it in to see if we're gonna get true or false statement. So you're gonna find it out. This one will be equal to 20. Is 20 less than or equal to 0? No, right? This is a false statement. Try the second one. Plug in 0 into this original inequality. Okay, you're gonna get negative 15 less than or equal to 0. So this is true statement. Good. Last one. Plug in 6. You're gonna get 9 less than or equal to 0. So this is a false statement also. So you could see the values in interval B make the inequality true. So we only have the solution on the interval B here. So our solution set will be brackets negative 3 to 5 brackets. So this is the only solutions that we have. So I want you guys, when you're solving the quadratic inequality, first, step 1, make it to equal sign. Solve for your x. Step 2, use the solution to divide it into 3 different regions. And then you're gonna think about what is your test value. Plug it in to the original quadratic inequality to see which part you're gonna get the true statement. Okay, let's try another example. I want you guys try to do it by yourself. First, step 1, make it equal to 0. And then use your x method, factor out. You should get x equal to negative 1/3 or x equal to 4. Okay, step 1. Step 2, draw the number 9 and write down the interval. Okay, negative 1/3 and then x equal to 4. Keep in mind our original inequality is strictly greater than. So we're gonna use the open dot here. Open means not equal to. and then write down on each interval from negative infinity to negative 1/3 parenthesis. In the middle, parenthesis negative 1/3 to 4. And then at the end here, there will be parenthesis 4 to positive infinity. Okay, then grab a table. Write down the interval here and then plug in the test value. So here I'm gonna plug in -1. Second one, I'm gonna pick 0 because it's easy number, right? Last one, you can plug in the 4, okay? Because this is strictly greater than, not equal to 4, okay? So you can put 5 here. And then plug into the original quadratic inequality. You should get 10 strictly greater than 0. So this is a true statement. Second part, -4 strictly greater than 0. This is a false statement. Last one. You should get 16 strictly greater than 0. So this is a true statement. So the values in the interval A and C make the inequality true. So this part and this part, we're going to get the true statement. And that will be my solution. Okay, solution set, that will be the disjoint, okay? From negative infinity to negative 1/3 or from 4 to positive infinity. Okay, get the idea, right? Now, solving a rational inequality. So this time we're gonna work with the rational inequality. Step 1, we write the inequality if necessary so that 0 is on one side and there is a single fraction on the other side. Step 2, determine the values that will cause either the numerator or the denominator of the rational expression to equal 0. And these values determine the interval of the number 9 to consider. Okay, set up either numerator equal to 0 or the denominator equal to 0. And this value, that will be help us to determine on the interval on the number 9. And then we're gonna use the test value. Okay, make up some test number to test on each interval. Okay, look at this example. Solving a rational inequality. Okay, when we have the questions like that, this is a rational number and this is an inequality. If you try to multiply x plus 4 for both sides, you have to be careful. Since the x is a variable, we are not sure the x is going to be positive number or negative number. Okay, if the x plus 4, you're going to resulting in a negative number. If you multiply x plus 4 for both sides, then you need to reverse the direction of the inequality. Okay, so you need to watch out if you have the questions like that. You don't want to multiply the x plus 4 for both sides. Instead, you may want to subtract 1 for both sides and then get the same denominator. Make it into one fraction, okay? Okay, look at this example. One more time, we don't want to multiply x minus 3 for both sides because the variable here, we may afraid that the denominator will have the negative number. So what we're gonna do, we're gonna subtract 4 for both sides. And then get the same denominator. The LCD will be x minus 3. Okay, now let's try to write as a single fraction. Okay, they do have the same denominator. So distribute the -4 for both of them. So -4x plus 12, okay? Negative, you're gonna get positive here. Now combine the 9 terms. Okay, right? So this is a greater than or equal to 0. Okay, what makes this guy equal to 0? When the numerator 18 minus 4x equal to 0, 0 divided by number, that will be equal to 0. So that will be our first solution here. 18 minus 4x equal to 0. And then remember on the denominator, this guy cannot be equal to 0. If this is equal to 0, a number divided by the 0, that will be undefined, right? So we're gonna write it down. First, the numerator, we set it equal to 0. And then for the denominator, we're gonna assume this is equal to 0 first. Okay, we're gonna figure out after. Solve for it, you find out x equal to 9 over 2 or x equal to 3. And then, just like the previous example, these two values will divide the number 9 into 3 regions. Okay, but be careful. X equal to 3, we just say that x cannot be equal to 3 because x minus 3 is on the denominator. So we're gonna use the open dot to represent this guy. X cannot be equal to 3. And then x equal to 9 over 2, I will be using the close dot because this is a greater than or equal to 0. Okay, when x equal to 9 over 2, that will be equal to 0. So this is good. So you have to be careful when we use the open dot, when we use the closed dot here. And then we're gonna write down the interval A, B, and C. Now we're gonna get the table here. Write down each interval. And then plug in the test value. So this is from negative infinity to 3, we'll be using 0. It's easier. And then we're gonna plug in the original rational inequality. Second part, interval B here, I'm gonna plug in x equal to 4. Last one, I will plug in x equal to 5. Okay, plug in to the original rational inequality. So you're gonna get negative 2 greater than or equal to 4. So this is a false statement. And then plug in x equal to 4. I'm gonna get 6 greater than or equal to 4. So this is good. This is a true statement. Last one, plug in x equal to 5. You're gonna get 3 greater than or equal to 4. So this is a false statement again. So we only have the true solution will be on the interval B, okay? So that will be our solution set. Parenthesis 3, comma, 9 over 2, brackets. That's it.